Hey, Doc Sig here to talk about empirical and molecular formulas and how to calculate them. First, let's understand the difference between an empirical and molecular formula. I'm going to start with empirical. So empirical is the lowest whole number ratio of atoms or moles of the elements in a compound. We use these for ionic compounds, and percent composition is used to calculate, which I have in another video I'll link. Molecular formulas, though, tell how many total atoms or molecules of elements, and that's it. We use those for covalent. All right, let's do some compare and contrast. So in the table down here, I'm going to start with butane, which is C4H10. That would be the molecular. The empirical, I would divide out by 2, so I'd wind up with C2H5, the lowest whole number ratio. Octane, C8H18, I can divide that all again by 2 to get the lowest whole number ratio, and I would wind up with C4H9. Glucose, C6H12O6. Divide by 6, and my empirical would be CH2O. So there you go. You have your molecular and empirical. So let's do the calculation. First, let's go through some steps on how we calculate them before we look at examples. First, if you're given a percent, you're going to assume it's out of 100 grams. That way you can make your percentage into a gram units. Then we'll divide by the atomic mass, not atomic number, but atomic mass of the element. We'll divide by the smallest number. If it doesn't give you whole numbers, you'll have to multiply to get a whole number. I have a whole table for you in an upcoming slide. Last, write the formula. Here's our first example. Determine the empirical formula for a compound which is 54.09% calcium, 43.18% oxygen, and 2.73% hydrogen. First, let's look at calcium. So I would have 54.09 grams per mole, because remember I'm turning that percentage to a gram quantity because I'm making the assumption out of 100 grams. We're going to divide it by its atomic mass. I get 1.35. Oxygen, 43.18 grams per mole, divided by its atomic mass equals 2.70. Hydrogen, 2.73 grams per mole, divided by the atomic mass, I get 2.70. Now, I did that step in white. I'll do the next step in orange to show you the difference. I'm going to take the smallest number and divide that by all three. So the smallest would be 1.35. So divide 1.35 by all numbers. For calcium, I get a 1. For oxygen, I get a 2. And for hydrogen, get a 2. So the last step I'll do in green, you write the formula. So I'd get calcium has a 1, oxygen has a 2, hydrogen has a 2. So I'd get CaO2H2. And really it would be written as Ca parentheses OH2. Let's try another. I'm asked to calculate the empirical formula for a compound which contains 36.80% nitrogen and 63.25% oxygen. Starting with the nitrogen, I would have 36.80 grams per mole divided by the atomic mass, which gives me 2.63. Oxygen, I would have 63.25 grams per mole divided by the atomic mass of oxygen equals 3.95. Okay, in orange, I'll divide by my lowest number, which would be 2.63. The nitrogen, 2.63 divided by 2.63 would give me 1. On the oxygen, I get 3.95 divided by 2.63, I get 1.5. So I have to have whole numbers. So I'm going to go down to this table down here, and I have a little rounding rule. If less than 0.20 or greater than 0.8, you can round to the nearest whole number. But if it falls between, use the table. So on this table, I wound up with 0.5 as my decimal. So it says the multiplier would be 2. So I'll go back up, and in fuchsia, multiply by 2. So 1 times 2 would be 2. 1.5 times 2 would be 3. So I'd wind up with N2O3. That would be my final step in green. All right, our last one is a two-parter. We have an unknown compound that contains 47.0 grams potassium, 14.5 grams carbon, and 38.5 grams oxygen. The first step, we're going to calculate the empirical formula. In the second, we are given the molar mass, and we're going to calculate the molecular. But first, step A. Potassium, 47.0 grams per mole. We divide by the atomic mass, I get 1.20. Carbon, 14.5 divided by atomic mass, I get 1.20. Oxygen, 38.5 divided by 16, its atomic mass, I get 2.41. Step 2, divided by the lowest number, and that would be 1.20. And I would get 1 for potassium, 1 for carbon, and I would get 2 for oxygen. I'd wind up with KCO2 as my empirical formula. Step A, done. So part B, if I'm given a molar mass and I need to calculate the molecular formula, well, first I've got to get my molar mass for the formula I just did the empirical for. So I have 1 potassium times the atomic mass, I get 39.1 grams per mole. Carbon, I have 1 times the atomic mass, I get 12 grams per mole. Oxygen, I have 2 times the atomic mass, I get 32.0. Add them all up, I get 83.1 grams per mole. And I have another video that I'll link here if you are stuck on molar masses you can refer to. So now I take the molar mass I was given, divide it by the empirical molar mass I just calculated, and I get 2. 2 times parentheses the empirical I just got, so the 2 would distribute in, and I would wind up with K2C2O4. And there you go, there's the molecular part B solved. Alright, until next time, see you later.